Objective: to understand the different types of atomic species. Think it over. According to Dalton, all atoms present in an element are same in all respects. Can this be true? Let's verify this statement. Consider two different atoms of carbon, that is, C612 and C614. Observe the number of fundamental particles present in each of them. The carbon atom represented by C612 contains 6 protons, 6 electrons, and 6 neutrons, whereas the carbon atom represented by C614 contains 6 protons, 6 electrons, and 8 neutrons. Observe that both these atoms contain the same number of protons and electrons, but they differ in the number of neutrons. Such atoms of an element are called isotopes. Isotopes are the atoms of the same element that differ in the number of neutrons. In other words, isotopes contain same number of protons and electrons, but different number of neutrons. Isotopes can also be defined as atoms of the same element with the same atomic number, but different mass numbers. Let's see a few examples of isotopes. Isotopes of hydrogen are protium, deuterium, and tritium. The most abundant isotope of hydrogen is protium, with an abundance of 99.98%. It contains only one proton and no neutrons. The abundance of the other two isotopes, that is, deuterium and tritium, is 0.015%. Deuterium has one proton and one neutron, whereas tritium has one proton and 2 neutrons. Lithium-6, lithium-7, and lithium-8 are the isotopes of lithium. C12, C13, C14 are the isotopes of carbon. On the other hand, chlorine has 2 isotopes, that is, Cl35 and Cl37. It must be noted that isotopes of elements other than hydrogen do not have special names. They are represented simply by indicating their mass numbers. As the atomic number of isotopes is the same, they occupy the same position in the periodic table. Isotopes have similar chemical properties, but different physical properties. Isotopes have the same number of electrons, so they exhibit similar chemical properties. Isotopes differ in the number of neutrons and mass number, so they have different physical properties. For example, chlorine-35 and chlorine-37 have the same chemical properties as they both have the same number of electrons in their valence shell, which is 7. They differ in their mass numbers due to the difference in the number of neutrons in them. Hence, they differ in their physical properties. Isobars. Consider the atoms of different elements like nitrogen 7, 17, oxygen 8, 17, and fluorine 9, 17. The atomic numbers of these elements are different, but their mass numbers are the same. This means that these atoms differ in the number of protons, but contain the same number of nucleons, that is, the sum of protons and neutrons. Such species are called isobars. Isobars are atoms or nuclides of different elements that have the same number of nucleons or same mass number. For example, carbon 614 and nitrogen 714 are isobars. Argon 1840 potassium 1940 and calcium 2040 are isobars. Another example includes xenon 54 130 and barium 56 130. Isobars have different chemical properties as they differ in the number of electrons. They show similar physical properties due to the presence of the same number of nucleons. Isotones. Observe the number of electrons, protons and neutrons present in nitrogen 717, oxygen 818, fluorine 919 and neon 1020. Each of these species differs in the number of protons and electrons, but contains the same number of neutrons. Such species are called isotones. Isotones are nuclides with different atomic and mass numbers, but they have the same number of neutrons. For example, silicon 1430, phosphorus 1531, and sulfur 1632 are isotones. Here all the atoms have 16 neutrons, hence these nuclides are isotones. Isotones show different physical and chemical properties.